Okay, so chapter 5, section 2, perpendicular and angle bisectors. We touched on bisectors before when we were talking about angles and segments. A bisector divides anything into two congruent parts. And here a perpendicular bisector divides a segment into two congruent parts and forms right angles. That is something you have to write down in your notes. Okay, so CD would be the perpendicular bisector of segment AB. It would also be the angle bisector of ACB. Now, if you have a hard time that's seeing that, there's the angle bisector, okay? There's where it bisects the segment. Okay, so theorem 5.2 says if a point is on the perpendicular bisector of a segment, then it's equidistant or equal distance from the endpoints of the segment. So AD would be congruent to BD, and CA would equal CB. Where they have an equal, they're not a congruent. So, okay, so also, they're telling me that those guys are congruent as well. Okay, which will be important for later on when we're talking about this more. Okay, so the converse says if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector. So if PA is congruent to PB, then PM is the perpendicular bisector. And MA would be congruent to MB. Okay? It would also mean that we would have right angles here. That was a bad drawing. Okay, so that would make 90-degree angles as well. All right, example 1. So we're going to use the perpendicular bisector theorem when we're doing these problems. Okay, so we know by the perpendicular bisector is DB. Okay, so here's my perpendicular bisector. I know it cuts the bottom two parts into congruent. So AD would be equal to CD, but these are also equal. Okay, so how do we solve that then? Okay, we set 4x equal to 6x minus 10. Okay, careful with all of these. We're going to solve for x, but it's asking me for the length of the side. It's going to ask me that almost every time to see what the actual side length is. Okay, so let's first solve for x. And I know you're thinking, okay, I'm going to get a negative here. 4x minus 6x is negative 10. Okay? But what happens when we divide by a negative and a negative? We get a positive. Okay, so my x value is 5. Okay? That's not the value of AB. That is just the value of what 5 is. Okay, so let's plug that back in for AB. And 4 times x, which is 5. So the segment is 20. We don't need to label it because they're not giving me any labels. Okay, so next one. So I know PR and SR are congruent, but remember I also know that these two sides are congruent, okay, according to the bisector theorem. Okay, so again, I'm going to set those two equal to each other, okay? Make sure you know that it wants the length of QR, okay? It doesn't want X, although you have to have X to find that, but that's not our ultimate goal, okay? So I'm going to move 3X over here. Okay, something happened. And I'll add 7. 6 is equal to 2x, so my x is 3. Okay? My whole screen moved for some reason, but... Oh, and FYI, QR should be QP. Okay, cross out that R and make it a QP. Okay, so QP would be 3 times 3 minus 1, which would be 8. Okay? Okay? I know that these are a lot of theorems and they might not make a whole lot of sense, but basically things are just equal to each other. So if a point is on the bisector of an angle, then the point is equal distance from the sides. Okay, so on this, here I'm going to go into my highlighter. And it doesn't need to be so big. Okay, so S is the point that's on the bisector of the angle. Okay, so that means that these two parts are congruent, which shows in this diagram over here. So it shows SP and SR are congruent. Okay, well, vice versa, if we know that those two segments are congruent, we know that there's a perpendicular bisector then going through it. Okay, so these are just saying the exact opposite things. Okay, this isn't anything confusing. Okay, they're just saying the exact opposite. So just a lot of things that equal. All right, so we're going to use the angle bisector theorem. Okay, so what's the length of RM? Well, I know that it's the bisector, so RM and RP would be equal length. So let's solve for x. Okay, minus 2x from both sides. 5x is equal to 25. Divide by 5, x is 5. Okay, so all we got to do is plug that in for RM. And we have 7 times 5. So RM is 35. Okay, so this is basically how you're going to set up every problem in this section. Okay, so CB. Let's find x. So subtract 4x. 2x plus 3 equals 9. Minus 3. 2x equals 6, so x is 3. Okay, so the length of CB is 6 times 3, which is 18, plus 3, which is 21. Remember, if you guys have questions when you're doing your homework, if I'm not there, message me on Canvas. Okay, I have the app on my phone, so it'll pop up right away when I'm at my conference. So just wanted to remind you guys of that. Okay, we're going to use the diagram to solve everything that they ask me. Just got to fix that quick. All right, so first of all, they tell me to find the value of x. So let's go ahead and do that. Okay, so I'm going to set 2x equal to 3x minus 5. Okay, subtract 3x from both sides. Then I have negative x equals negative 5. Okay, I got to divide by a negative 1. Or if you're my daughter, you can just erase the negative. I'm kidding, that does not work, obviously. So I found my x to be 5. Okay, that's all they asked me in part A. Now they want me to find TW, okay, which is 2x, so I'll take 2 times 5, and TW is 10. Okay, then they want me to find WZ, and it should be the same length. So 3 times 5 minus 5, 15 minus 5, all right, so we've also got 10. So what I'm saying is those sides are congruent. Okay, what kind of triangle is TWZ? Okay, it's an isosceles triangle. Okay, now I know this may sound confusing because you don't have an R, okay, but what they're saying is if for some reason there was an R here on the perpendicular bisector, okay, then what is its relationship from T and Z? Okay, it's equidistant, just like Y is up there. Okay, or what would that mean? That would mean TR would be equal to ZR, just like ZY is equal to TY. Okay? All right. Last page. Okay, so we're going to use this figure to solve. Okay? So what they're asking here is is how far is L from HK? Okay, so how far from L to HK is it? And then how about from HF? Okay, this is not trying to be confusing. Some people get a little confused at this part. But what's the length of L to KH? They give it to me right here. 27. Okay, well, I know that's congruent. So from HF, it's also 27. Okay, not trying to be tricky. It's just as simple as that. How is HL related to angle KHF? Okay, so KHF, whoops, is that angle right there. So how is HL related to it? Okay, well, HL is the angle bisector. Okay, which means it's going to split the angle KHF into two congruent angles. The two angles would be angle KHL. That would be congruent to angle FHL. I'll erase that so you can see. Okay, so HL will be the angle bisector. Okay, now it wants us to find the value of y. So let's go ahead, and we know that those two are congruent according to our theorem. So subtract 4y and divide by 2, y is 9. So that's all they wanted me to do in this one. Okay, then they want me to find the measure of KHL and FHL. Okay, well, these arrows are actually pointing to the angles, so we just need to plug y back in. So 6 times y would be the measure of KHL, and 4 times y plus 18 would equal the measure of FHL. I wanted to put 9 in there. Okay, so that's 54. This hopefully is 54, and it is. Okay, so this stuff isn't hard. You're equaling everything to each other and plugging x in. Don't forget the plugging back in part because that's important. Like I said, you'll have a worksheet. We'll have another video lesson tomorrow in Chapter 5, Section 3. Any questions, you need to contact me via Canvas. That would be awesome. Behave, and I will see you guys when I get back.